Today I'm going to teach you about remote sensing. First of all, we will get to know about its definition. Then, we will get to know about the small introduction. Then, we will learn about types and scope of remote sensing. After that, I will explain you applications of remote sensing. So, first of all, the question arises, what is remote sensing? So, without any late, let's get started with the video. What is remote sensing? Remote sensing, it is the collection of information relating to objects without being in physical contact with them. Thus, our eyes and ears are remote sensors, and the same is true for cameras and microphones and for many instruments used for all kinds of applications. Or it is said in another way, what is remote sensing? Remote sensing is the process of acquiring data or information about objects or substances not in direct contact with the sensor by gathering its inputs using electromagnetic radiation or acoustic waves that emanate from the target of interest. An aerial photograph is a common example of a remotely sensed by camera, and film or now digital product. Introduction to remote sensing. The sun is a source of energy or radiation which provides a very convenient source of energy for more remote sensing. The sun's energy is either reflected as it is for visible wavelengths or absorbed and then emitted as it is for thermal infrared wavelengths. There are two main types of remote sensing. First one is passive remote sensing and second one is active remote sensing. There are two main types of remote sensing. First, passive remote sensing and second, active remote sensing. In the diagram, you can see first image is passive remote sensing and the second one is depicting active remote sensing. After that, I will teach you about types of sensors. First one is passive sensors. Passive sensor detect natural radiation that is emitted or reflected by the object or surrounding area being observed. Reflected sunlight is the most common source of radiation measured by passive sensors. Examples of passive remote sensors are passive remote sensors include radiometers, infrared and film photography. Previously, we have discussed about passive remote sensing and second one is active remote sensing. On the other hand, it emits energy in order to scan objects and areas where upon a sensor then detects and measure the radiation that is reflected or backscattered from the target. Radar is an example of active remote sensing where the time delay between emission and return is measured, establishing the location, height, speeds, and direction of an object. Overview to remote sensing. Remote sensing makes it possible to collect data on dangerous or inaccessible areas. Remote sensing applications include monitoring deforestation in areas such as Amazon basin, the effects of climate change on glaciers and Arctic and Antarctic regions, and depth sounding of coastal and ocean depths. Military collection during the Cold War made use of standoff collection of data about dangerous border areas. Remote sensing also replaces costly and slow data collection on the ground, ensuring in the process that areas or objects are not disturbed. Applications of remote sensing. There are probably hundreds of applications. These are typical mentioned below. Meteorology, study of atmospheric temperature, pressure, water vapor, and wind velocity. Oceanography, measuring sea surface temperature, mapping ocean currents and wave energy, spectra and depth sounding of coastal and ocean depths. Glaciology, measuring ice cup volumes, ice stream velocity, and sea ice distribution. Glacial geology, identification of rock type, mapping faults and structure. Geodesy, measuring the figure of the earth and its gravity field. Topography and cartography, improving digital elevation models. Agriculture, monitoring the biomass of land vegetation. Forest, monitoring is the health of crops, mapping soil moisture. Botany, forecasting crop yields. Hydrology, assessing water resources from snow, rainfall, and underground aquifers. Disaster warning and assessment, monitoring of floods and landslides. Monitoring volcanic activity, assessing damage zones from natural disaster. Planning applications, mapping ecological zones. Monitoring deforestation, monitoring urban land use. Oil and mineral exploration, locating natural oil seeps and slicks, mapping geological structures. Monitoring oil fields subsidence. In military, developing precise maps for planning, monitoring military infrastructure, monitoring ship and troop movements. In urban, determining the status of a growing crop. In climate, the effects of climate change on glaciers and Arctic and Antarctic regions. In sea, monitoring the extent of flooding. In rock, recognizing rock types. In a space program, it is the backbone of the space program. Seismology as a premonition. In the end, I would like to thank you, all of you, for being a wonderful audience. If you really like this video, then please comment, like, and subscribe, and share with your friends who need this video. If you need the latest updates of these kind of videos, then please hit the bell icon for the latest updates and notification for the latest videos. Thank you so much